Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at configuring IP static routes. We'll be discussing next hop static routes, directly connected static routes, and fully specified static routes, and we'll look at each of those for IPv4 and IPv6. This episode is part of my series on switching, routing, and wireless essentials for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. When we look at static routes, one of the ways we can configure them is a next hop static route, meaning we specify an IP address of that next hop that we're going to. We're going to talk about IP version 4 right now. We're going to start on R1. Each router, when you talk about the routes in creating static routes, they need its own conversation, because you need to be basically thinking, okay, I'm in router 1. How do I get to these other networks? Router 1, and we've got 5 networks here. This is network 1. I'm going to call this network 2, network 3, network 4, and down here is network 5. We have 5 different networks on there. Router 1, network 1 is directly connected. Network 2 is directly connected. So I know about these networks. They're directly connected. They're going to be automatically in my addressing table. I know how to get traffic to those networks. The other networks, network 3, I have to go through R2. So it's not directly connected to me. It's a remote network. Network 4, I have to go through R2, not directly connected to me. That means this is a remote network. And network 5 down here. This, I have to go to R2, and then I even have to go to R3. That is a remote network for me. Router 1 has 2 directly connected networks and then 3 remote networks, 3, 4, and 5. I know how to get to network 1, network 2 because they're directly connected. What we have to do is set up static routes to point traffic if traffic is destination for network 3, 172.16.1.0/24. If it's destined for that network, I have to send it this direction. Once again, we have two choices. We can do the next hop IP address, or we can do the exit interface. For this one, we're going to talk about the next hop IP address. What the next hop IP address is an IP address we know about, but it's on the next device. It's on the next router. Router 1 knows about network 1, network 2. But we need an IP address that's on that next router. This is the network right here. This is network 2. This is 172.16.2.1. and then 172.16.2.2. Because I have to send the data to the next router, it needs to be an IP address right here. And so the next hop IP address is on the network I know about because it's directly connected, but it's the IP address that's not on me, but on that far end of the device. And that gives us the 172.16.2.2 is our next hop address to get to network 3. Okay, if we want to send information to network 4, 192.168.1.0/24, we want to send it to this network. What's our next hop IP address? Well, we have to go to R2 here. That means it needs to be on a network we know about, so that is network 2, but it has to be an IP address on the far device where we're sending it. And that's the same address again, that 172.16.2.2. That is the same IP address. And then we have network 5 down here. If we want to send information down to this bottom right-hand network, the 192.168.2.0 network, bottom right network, what is the next hop IP address from R1? Well, the next hop IP address, once again, needs to be on a network that's directly connected to us, but it can't be our IP address. It needs to be the IP address on that next device, on that next router. It's 172.16.2.2 is this next hop, even to get to the network where I have to go through another router. Once again, the idea of the routers is getting it one step closer to the destination. And what happens here, when you're on R1 and you're sending information to network 3, we send it to the next hop IP address, which is R2. R2 says, hey, that network is directly connected to me. We can then route it to its destination. Same thing with network 4. R1 has information destined for network 4. We send it to that next hop IP address. R2 gets it and says, hey, that network is directly connected to me. I can then get data to network 4. If you want to send to network 5 down here, that bottom right one, 192.168.2.0, and you're on R1, you have to send it to the next router, that next IP address. Then that router gets it and says, okay, it's destined for 192.168.2.0. So that's not network 3. That's not network 4. The two networks that are directly connected to me. I don't look at the network it came in on. I look at the other networks that are direct. It's not there. Now, when router 2 gets it, at this point, it's going to say, I don't know what to do with it because I don't have a routing table. What you have to do is create another static route. So you have to create a second static route here that says to get to network 5, right? To get to network 5, you have to go to the next hop IP address. Well, on R2, the next hop IP address is on a network that's directly connected to me. That would make it this network right here. But it has to be the IP address not on R2, but on that next device we're going to. That would put it down here. And so your next hop IP address would get down to here. It would send the information to R3. R3 says, hey, that next network is directly connected to us. We can then deliver it to its destination. Every time a router gets it in, it either has to go to a directly connected network, or you need to have another static route that points to how to get there. And so R2 is going to have a static route that points to the next hop IP address on R3. Okay, let's take a look at how we actually implement this. On R1, what we're going to do, we're going to use the IP route command. And we're going to say, this is our destination network. So this is our destination network, destination subnet mask. Our destination network, 172.16.1.0. 172.16.1.0. Once again, this was network 1, network 2, network 3, network 4, and network 5. Oh, put network 5 up over here. This is network 5 down here. The network 172.16.1.0, that's our network 3 address. Now, it's not directly connected. That's why we're setting up the static route, and we're going to send it out. And this is that next hop IP address, 172.16.2.2. That's the next hop IP address. If we go back here and look at the command, IP, because we're part of the IP suite, we're dealing with routing, so the keyword here is routing. Put our destination network address, that's our network 3 address. Put the subnet mask in there, and then you put your next hop IP address, 172.16.2.2. Once again, that's that address up here on R2 that R1 knows how to route to because it's a directly connected network. That will route all traffic to the next hop IP address for network 3. Then we have the next command, what IP route 192.168.1.0. That's network 4 over here. To send information that way, next hop IP address from R1 is 172.16.2.2 right there. And then finally, we have the 192.168.2.0 network. That's our network 5 address right there. And it has to get to that far network. The next hop IP address is the address up here of serial 010, again, that 172.16.2.2. Yes, there is a pattern. When you set up your static routes and you're using next hop IP addresses, they're typically going to be the same IP addresses as long as they're going out the same direction. Once we go ahead and create those static routes, then we can do is show IP route. We're going to filter here and begin with the gateway. That way we don't get all the codes and everything at the top. We can see that we have the parent class full network of the 172.16/16 network. And we have our 2 directly connected local addresses in here because those are the interfaces we configured. We also get an S network. That's a static route here that says 172.16.0. Any traffic destined for this network, you have to go through the 172.16.2.2 address. So from R1, we have to send it up here to this address. Now, it may not be the final destination. It may be the final destination, but R1 knows it needs to send it up here to R2. Because it's the 172.16 in the first 2 octets, it falls underneath the parent of the 172. Down here, we have 192.168.1.0 network. 192 is a class C, so it gives us a 24 subnet. Notice how it's out here as a parent. Any traffic destined for the 192.168.1.0 network, that is our network 4 over here. Router 1 knows it has to send it to the next hop IP address on R2, which is the 172.16.2.2 network. Then our final entry for our static route 192.16.2.0, that's our network 5 way over here on the bottom right of our network. We have to send it to that next hop IP address because R1 is just responsible getting it to a step closer to its destination. It's not going to get it to its final destination sometimes, but it's at least going to get it a step closer. And that's that next hop IP address up here on R2. At the top here, we configured our static routes. Down here on the bottom, we're displaying the information about our static routes. IP version 6 functions the same way. Next hop IP addresses. Once again, we're starting our conversation from R1. And this is network 1 here, network 2, network 3, network 4, and network 5. Router 1 knows about these 2 directly connected networks, 2001 DB8 AC AD: 3 and 2001 DB8 AC AD: 2 : It knows about these 2 networks that are directly connected, but to get to the other networks, network 3, network 4, and network 5, they all have to go through that next hop IP address. The next hop IP address right here is, it needs to be on a network we know about, but it has to be an IP address on that far router. That's this point right here. That gives us 2001 DB8 ACAD: 2 : and then it'll be a 2 at the end with a /64. Our next hop IP address to get to network 3, 4, and 5 is this IP version 6 address up here on R2. How we set that up here? Gotta remember, anytime we're doing IP version 6 routing, you need to turn it on. You need to enable it. That's what this command does right here. It turns it on. You have to remember to do that. If you don't do that, you're going to enter these commands. you're going to get an error saying, I can't route IP version 6. Well, I'm typing it in correctly. You have to turn it on. So it turns on. Got to make sure you do that command. Once you've turned it on, you can go ahead. And it follows basically the same pattern. We're dealing with the IP version 6 protocol suite. So we start off with IPv6. We're dealing with routing. So the next word is routing. Then we put our network address in here of the FAR network we're trying to get to. First one we're trying to get to here is our network 3. Let me go ahead and label these once again. Network 3, network 4, and network 5. We're trying to get up here to network 3, and we put our network address in here. Once again, network addresses, they're called prefixes in version 6. They end in zeros. And then you put your slash for your prefix. We're using half of the 128 bits available, so it's a /64. And then you put your next hop IP address. That next hop IP address, once again, is right here. And that comes from there. Now we can go ahead and do network 4. This is network 4 here. This was network 3, network 5. IPv6, then we put IPv6 route, and then we put the network address of network 4. That's over here. Once again, we end in zeros. Or sorry, I keep calling network address. It's the prefix for IP version 6. And then we put our next hop IP address in there. It's the same address we entered in the line above. And finally, to get to that last network, network 5, we go from router 1, but we have to go to R2. R2 is not the final destination. R2 is going to send it on to R3. But right now, we are going to just say to get to network 5, this far bottom right network, we still have to go to that next hop IP address. Once again, right there. So all three of these have the same same next hop IP address. When we go ahead and do a show IP version 6 route command, you can barely see it right here. We get the codes up here. We have our configured interfaces that give us our connected networks, our local connections. Down here is our link local address. Right here is our 3 different networks. Notice there's no parent-child because there is no there's no class full addresses in IP version 6. Right here we have this network, 2001 DB8 ACAD. That's for our network 3. Right here we have 2001 DB8 CAFA:1. This is for our network 4. And the last entry in our routing table is for network 5. Notice they all have that same next hop IP address, which, as we look at the charts, that's how we get to these networks, is they all have to go through that next hop IP address right there. I hope you're liking this episode on configuring IP static routes. If you have the time, please leave a comment and let me know what you think about IP static routes. You can also visit my website at KevTechify.com. All of my details and how to get these episodes in video and podcast form. Directly connected networks, similar to that next hop IP address, but instead of talking an IP address, we're going to talk exit interface. Now, the interface is the interface on the router. It's a gig 000, it's the serial 010. It's what interface do we send it out? Once again, we're going to have our conversation start on R1. First time through, we're going to talk about IP version 4. We have our 5 networks again: network 1, network 2, network 3, network 4, and network 5. Network 1, network 2 directly connected. I know about them. But network 3 is not directly connected. I need to get the traffic up to R2, so R2 can then hopefully get it to its destination. We're not going to use the next hop IP address, which would be right here. What we're going to do is say go out the interface on R1 that'll get you to another device that'll get you one step closer to your destination. Which interface on R1 gets us closer to our destination? Gig 000. Well, that goes back to our local network. That's going the opposite way. Serial 010, that goes up to R2. That's where we get it one step closer to its destination. This is the exit interface. And once again, if we look to get to network 3, we have to go out serial 010. To get to network 4, we have to send it up to R2 again. That goes up here to R2. That goes out that serial 010 interface. To get to network 5, we have to send it out the serial 010 interface to get to R2. And then if we wanted to make sure it got all the way there, we would need to set up another static route that says to get to network 5, you have to go out that interface there. That would send it down to this one. R3 would get it and say, hey, that's a directly connected network. I can then deliver it to its destination. Always got to make sure that each remote network has a static route. Let's go ahead and configure that. Here's the 3 commands to configure that. Once again, we're in global configuration mode. First one we're going to do, let me go ahead and just label these quick for a second. Network 2, 3, network 4, and network 5. 1 and 2 we know about because they're directly connected on R1. Network 3 is a remote network because we have to go through another device, another router to get there. And we started off the same way as we did with the next hop static route. It's part of the IP suite. We're dealing with the routing, so it's IP route. Then you put the destination network address. Once again, network addresses end in 0. You put in the subnet mask for that. We can see that that's right here on the information given to us. And then instead of putting that next hop IP address right here, we put that exit interface. We put the exit interface that is going out serial 010 right here. That's our exit interface. Then we come down here. So that was network 3. Come down here for network 4. Same thing, IP route. We put the destination network. Destination network for network 4 is 192.168.1.0. Go ahead, we put that in there. Once again, network addresses end in 0. Put our subnet mask on there and our exit interface. To get to network 5, we put the command in here for network 5, IP route. We put the network address, 192.168.2.0, put the subnet mask, and then the exit interface off of R1 to get it one step closer to its destination. It's going to go out of serial 010. And with how this network is set up in all 3 of these examples, they all use the same exit interface here on R1. Thing to note, you should always try to use that next hop IP address. Routing just works better that way. If you actually get into the code and the actual understanding of the iOS for the Cisco router, it processes that next hop IP address better than that serial interface or that exit interface. The only time you should use a directly connected static route, that exit interface, is on a network where there's only 2 connection points. That's what we call this point-to-point network. This network that goes between R1 and R2 is a point-to-point. You're not going to connect any other devices in there. That gives us just the point-to-point, and that exit interface comes out here. It has to go in the other end of the cable right there. There's another point-to-point connection on this network that's between R2 and R3. That's where you could use that exit interface, but you typically always want to use that next hop IP address. We went in here, we entered in our commands up here. Now we did a show IP route, and we began with the gateway statement. We filtered it. We start off here with the parent address of our 172.16.0 network. Network 3 from our topology 172.16.1 is right here. Once again, S gives us that's a static route. Directly connected to serial 010, that's our exit interface. Last two lines here give us our other two networks, network 4 and network 5. We have our network addresses. Once again, these are Class C addresses, so they appear as a parent. And then they give us our exit interfaces here again on R1, which is our serial 010 interface. IPv6 for a directly connected a directly connected static route. Once again, we use the exit interfaces. It actually uses the same interface. Network 1, network 2, network 3, network 4, and network 5. Network 1, 2 we know about, but for these remote networks, network 3, network 4, network 5, where we have to go through another router, for R1, we need to set up those routes. And to get there, we have to go out an interface that connects us to that R2 router. That is that same interface again. So between IP version 4 and IP version 6, that final component of a directly connected static route is going to be the same. It's going to be serial 0100. Where if you're using the next hop IP address, it'd be an IP version 4 address or an IP version 6 address, depending upon which one you're doing. But for here, the directly connected static route, it's going to be the same network. And to get to all three of these networks, network 3, network 4, network 5, you have to go out that serial 1 or serial 010 interface. Here's our commands. Once again, remember, you should do the IP unicast routing first. If you haven't done that, make sure you have IP version 6 routing turned on. Then our command is basically the same as we've done. So IPv6, we're dealing with routes. You put your destination network in here. Once again, our destination network, our prefix address ends in zeros because it's just the prefix, the network portion, and our exit interface. Exit interface, once again, is serial 010. That gets us one step closer to our destination. And so let me just label my networks again. Network 1, network 2, network 3, 4, network 5. That takes care of network 3. Network 4, go ahead and put our prefix address in there. Ends in zeros. Goes out that same exit interface on R1. Gets us one step closer. Serial 010. And then we put in to get to network 5. The last remote network. 2001 DBA CAFA 2:::. Gotta remember it ends in zeros, and that goes out that same interface. All three of these go out the same interface. We do a show IPv6 route command here. It scrolls behind. It gives us our networks. Here is the one network. Here is the second one. Third one, easily identified by the S for a static route. This here is for ACAD1. This is for network 3. CAF1 is network 4 and network 5. Notice we have our network addresses, and then it tells us what interface on R1 do we have to go out of to get to our destination. We need to go out serial 010. Last way to do it is a fully specified, where we identify the exit interface and the next hop IP address. We're going to use the same topology again. Network 1, network 2, network 3, network 4, and network 5. Our conversation, once again, will start with R1, but this time we're doing fully specified. So we need the exit interface and we need the next hop IP address. To get to network 3, our first remote network, we have to go out this direction. We have to go this way. That means we have to go out the serial 010 interface, and then we have to go to the next hop IP address. That needs to be on a directly connected network. That's our directly connected network, but it has to be the IP address on that next router. That would be this address right here, which gives us 172.16.2.2. To get to our network 3, same thing to get to network 4, we have to go up to R2. Exit interface, IP address. To get to network 5, we have to go, same thing, serial 010 is our exit interface, 72.16.2.2 is that next hop IP address, gets it up to R2, and then you have to say, okay, now to get to R2 to R3, or sorry, it really shouldn't be from R2, it should be from R2 to network 5. We have to go out this exit interface, and we have to go down to this IP version 4 address. That will give us a fully specified static route. Here's the commands to do that for IP version 4. We start off with, I'm going to go ahead and label my networks quick. Network 1, network 2, network 3, network 4, and network 5. Start off with IP route. We're dealing with the IP suite. We're dealing with routing. Put our destination network in here. This is for destination network 3, 172.16.1.0. That's what we got right here. Put in our subnet mask. Then we say, what is our exit interface? Our exit interface is not gig 001. It is a typo. It is serial 01. Serial 010 is our exit interface, and the next hop IP address is right here. Our exit interface is here. Exit interface right there. Next hop IP address right there. That gives us a fully specified network. These are actually all wrong in the demonstration. These are all serial 0/1/0, serial 0/1/0. To get to network 4, we start off the same way. Put our network address in here, 192.168.1.0, subnet mask, then the exit interface, which is serial 010, and then that goes to our next hop IP address up here on R2, 172.16.2.2. And to get to network 5. Once again, network 5 won't get it to its final destination, but it's going to get it one step closer. Put in our network address, put in our exit interface, and we put in our next hop IP address. When we go and look at the show IP route statement, we can see underneath the parent of 172.16, network 3 is listed right here, 172.16.1.0. To get there, our next hop IP address is 172.16.2.2, which comes in from here, and then it lists our exit interface. And because we entered it wrong up here, it's giving us the wrong information, but this should be serial 0/1/0. If it follows our example, coming down here, this is network 4 and network 5. We have our network addresses in here. Once again, remember, network addresses end in 0. To get there, our next hop IP address is 172.16.2.2. And then our exit interface, because we have a typo at the beginning, it carries all the way through. This should be serial 010, serial 010. IPv6, there's a little bit of a twist here when we put in our IPv6 fully specified address. In this example here, we have R1 to R2. R1 to R2, we want to forward traffic to this far right network. And so we've got three networks. This is network 1 here, this is network 2, and then we have network 3 over here. Now, network 3 is basically right here. Network 2 goes from here to here. And network 1 is over there. R1 wants to route traffic to network 3. So we have to point next hop IP address to this IP version 6 address over here, 2001 DB8 ACAD :2:2/64. That would be our next hop IP address. Or we have the link local address. The link local address is where we come in for a problem. Because remember how in IP version 6, the link local address is only valid on that local area network. It's only valid there. And you can have, if you have multiple local area networks, you could have that same link local address be used in multiple locations. Because this next, if this was our next hop IP address for R1, so this would be the next hop here, you would go ahead and put it in the routing statement in a fully qualified. So IPv6 route. This is our destination network. So this is our destination. And then we have our next hop IP address. This is the link local address. And that goes to here. But because the scope of the FE80 link local address is only for the local network, because that link local address can exist on more than one local area network, routers connect up to local area networks, that link address, FE80::2, it could exist on network 2. It could also exist somewhere on network 1. FE80::2 could exist over here. Router 1 would not know where to send it. And so we can't do a next hop IP address using the link local address for IP version 6, but you can do a fully specified where you specify the link local address and you also specify what interface to send it out. We specify it needs to go out serial 010, and the next hop IP address is FE80::2. This will work. Notice how when we entered in the first time without the exit interface, it gives us an error and it actually doesn't set it. If we show the IP version 6 route here, notice we have a static route, but it does not use the global address because that's how we've entered it in there. It doesn't know that's how we get there. It only lists out the link local address. To verify a static route, we have the standard commands available to us. We have the show IP route. That's what we've used in these previous examples. Show IPv6 route. What we've done for IPv6. Once again, if it just says IP, this is for version 4. If it says IPv6, it's for version 6. We have the ping that sends out the echo reply and hopefully, an echo request, and hopefully you get the echo reply back. Then we have the trace route where it sends out an echo request to every router along the way, and then it logs the echo replies back in. There are a couple other useful commands. show IP route static, and that'll just give us all the static information for the routes. It won't list out any directly connected or local addresses. It won't list out any routes learned through dynamic protocols. Another command is show IP route network. Gives us all the network statements from our show IP route. And the last one we can use here is show running config, and then filter it for just the sections on IP route. And of course, to do all these commands up here, you replace IP with IPv6 to get into IP version 6. It was my pleasure to provide you with this wonderful episode on configuring IP static routes. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.